Oh, for this.
Okay, Jennifer, this video is for you. Jennifer?
You here?
All right, so here is the NGSS, okay? So not only does it have a lot of pages, it's very thick cognitively and difficult to understand. So I have, of course, printed out the paper copy, and I have just divided it into the DCI, disciplinary core ideas, versus the topic arrangements, all right? So we're gonna look at the disciplinary core ideas first. The two versions have the same information, but just in a different kind of format. So let's look at this one first, because I think it is more known. And here's how you read it. So we mentioned this a little bit earlier when I showed you my version of the chemistry teach. So what you see there, hold on a second here. Whoa, whoa, Nellie. That was my horse. She used to run really fast. He did not like anybody beating her, and another horse beat her. All right, so here's how you read it. So the first letter is K, that'd be for kindergarten. The second letter is, or two letters are PS, physical science, and then 2, and the strand for 2 is motion and stability. Okay, and then of course page 5. So if you go on down, you will see KPS3, so that strand is energy. And then LS, which is life science, but notice it goes not 1, 2, 3, but 2 and 3. So that means that 1 down here, where's 1? Okay, 1 down here, CPS1, matter and interactions is not going to be in kindergarten. That's what that kind of sequence means. So then we have LS, which is life science, 1, ESS, earth, space science, 2, 3, and so those are all of the strands that in science should be taught at the kindergarten level. So it doesn't mean that you can't teach things outside of that, but it means it's probably not cognitively appropriate. The kids can't understand it. And if you teach them these basics, they're not going to have problems later on understanding some of the more complex ideas. So here's first grade. So it says first grade storyline. So they will have a storyline at each one of them. I forgot to mention there's a kindergarten storyline. I can pull that up here. Okay, so here's the kindergarten storyline. The performance expectations in kindergarten help students formulate answers to questions such as, what happens if you push or pull an object harder? Where do animals live and why do they live there? What is the weather like today and how is it different from yesterday? Kindergarten performance expectations include PS2, PS3, LSI1, ESS2, ESS3, and ETSI. The disciplinary core ideas from the NRC framework, period. Students are expected to develop an understanding of patterns and variations in local weather, the purpose of weather forecasting to prepare for and to respond to severe weather. Students are able to apply an understanding of the effects of different strengths or different directions of pushes and pulls on the motion of an object to analyze a design solution. Students are expected to develop understanding of what plants and animals, including humans, need to survive and the relationship between their needs and where they live. The cross-cutting concepts of patterns, cause and effect, systems and system model, interdependence of science, engineering and technology, and the influence of engineering, technology, and science on society and the natural world are called out as organizing concepts. Okay, so here's the introduction that says, here's what they should learn, and here is how it's organized.
Rose, can you show where you're reading that on the Elmo?
No, I'm not.
Yeah.
No, I'm not reading that page on the elbow.
No, I'm saying can you?
Oh, can I? Oh, duh, yes. All you have to do is ask them.
Heather's like, whoa, okay.
Okay, here's the reason, here was what I was thinking about. I was thinking about showing you just how to organize in the table of contents, and then we go to your teaks, to your strand that you're gonna be working on. And then I thought, well, they probably need to understand what a storyline is, and a storyline is just like an introduction. This is what, in general, they're gonna do. So, and I thought elementary would be easier than some of the others. You all need to look at the storylines for your concept in elementary and middle school and high school. So you can see the difference between them. Anyways, here, okay, thank you. So here is the storyline, and I got down to, no, I'm sorry. Here's the storyline for kindergarten. Can y'all see that? Okay, good. Where was I? Disciplinary core ideas. In the kindergarten performance expectations, students are expected to demonstrate great appropriate proficiency in asking questions. Notice how important that is. Not memorizing vocabulary, asking questions. Developing and using models, planning and carrying out investigations, analyzing and interpreting data, designing solutions, engaging in argument from evidence. That goes back to that question I told y'all that you need to memorize. What is the evidence for your answer? That's what this is saying, just in different words. And obtaining, evaluating, and communicating information. Students are expected to use these practices. Remember I told you they're no longer called science skills anymore. They're not called process skills in the new standards, they're called practices. To demonstrate understanding of the core ideas. So that's the kindergarten storyline. On the page before it, it tells you in general about the elementary standards. If you want to read that quickly. So that gives you the kind of an overview of what you should think about what kids should learn in elementary. So in general, the storyline for kindergarten, and then they get into the next page, which is kindergarten PS2, motion, stability, forces, and interaction. So what you see in the NGSS are actually assessments. So it says if a student knows what they are supposed to know from the disciplinary core ideas here in orange and the cross-cutting concepts like cause and effect. See, this is content here and practices here. So cross-cutting concepts like cause and effect, and then science and engineering practices, planning and carrying out investigations, analyzing and interpreting data. Okay? Remember I told you it was thick? Then, if you look down here at the bottom, it says connections to other DCI, disciplinary core, in kindergarten. So, I forgot that's, I think it's Ed Tech, I've forgotten what that is. And then articulation across grade levels, so it shows you different grade levels here through 2 through 4. So how this idea of forces and interactions is developed across those grade levels, and it gives you very specific standards like this, so you can follow it across through grade 4. And then it has Common Core standards and connections. So NGSS is not Common Core, but sometimes those who are opposed to Common Core will say it's Common Core. Okay? It is not Common Core. What it does have, though, which is good, is it links to the math and the ELA in Common Core, because there's a lot of states using Common Core. So this says ELA literacy, and it gives you their dimensions in Common Core and their language, which I don't know what it is, but that's what, I mean, because I don't know what Common Core, I don't know what Common Core looks like. I haven't looked at it, because it's English and it's math. So, I don't look at it. But anyway, it makes those connections, and that's good, because you want math and science and English to be integrated together, to be used together. And I'll give you a reason, a good reason why that happened. I told you this at the state board meeting, that there were teachers who wanted to take infer, using indirect evidence, out of the 5th grade piece. And one of the elementary teachers said, well, wait a minute, 2nd graders have to make inferences in ELA. So you see why it's important to know those connections, kind of in general, if you would, not specific like a ELA teacher would. So they make connections here to Common Core, but if you look, okay, here we go. So if you look up here, what you see are actually, I call 2 assessments. So one assessment on students' understanding at kindergarten, forces and interactions, it says that students who demonstrate understanding can plan and conduct an investigation. Not the teacher doing it, but the students planning it. So that's where you want to move to compare the effects of different strengths or different directions of pushes and pulls on the motion of an object. Okay, so that's like a test question, if you would. Only it's a lot more than a test question, not like multiple choice. Now, remember I told you they also have clarification statements, which says, here's what it means in other words. So it means examples of pushes or pulls could include a string attached to an object being pulled. Well, does that sound like a lab or some kind of activity kids could be doing? Sure. So it gives you that kind of information. And then it says a person pushing an object, a person stopping a rolling ball, and 2 objects colliding and pushing on each other. So those are all examples that gives you, as a teacher, of what kind of activities these kids should be using to learn about this concept. Okay? Then it says, don't do this part though. Don't go this far with its, here, assessment boundary. So it says, assessment is limited to a person pushing an object. Is that right?
No.
Go down, yeah. Okay, assessment is limited to different relative strengths or different directions, but not both at the same time. So there's not, these 2 interactions going, which makes it too complex. It's not cognitively appropriate for them. Assessment does not include non-contact pushes or pulls, such as those produced by magnets. Okay? So you see how valuable this document is? I mean, it really does help you think about what your lesson should be about. And I want to go back to these here. So here's the disciplinary core ideas in orange. So this is like the science, if you would, or the types of examples. ETS is the engineering standards. So it says, remember that engineering, science, ask a question. Engineers define a problem. See right here where it says defining engineering problems? So that's the difference between science and engineering. It's not the same thing, and many people, teachers, use it interchangeably. I have before I really got into it and understood it better. And then the cross-cutting concepts like cause and effect, you know what that is, and that's what they're putting it in that category. And then science and engineering practices, planning and carrying out investigations, analyzing and interpreting data. All right? So when you get into your chemistry teaks that we're going to look at shortly, maybe that will help you. I know, that smells so good. I gave one to my son last night to take home to his wife, and he put it in his truck, and he said, I may just keep this in my truck, that smells so good. Okay, so does that give you a better idea then?
Yes.
So now, let's go back to the table of contents that I tried to start at. But I actually am glad that happened, because what I hope it demonstrated to you is that you get into a lesson and you figure, whoops, no, I need to do something a little bit different here. Then you need to do it, whatever your students need. Okay, so we got through kindergarten, so then there's a first grade storyline, and then the physical science, only one though, 4, waves and applications. That is a hole in our TEKS. Our state standards do not have waves in it. Up until you get to maybe IPC, high school. I used to do waves with my 3-year-olds in Montessori school with jump ropes. So we get a long jump rope, we'd make waves, and then we'd make faster. But before we did that, so we'd make a wave, and I'd have one student, you're it, so I'd have one student stand wherever the top of the wave is. They couldn't understand the difference between the top of the wave and the bottom of the wave. So they'd stand, I'd say, okay, let's do it faster. Do you have one top of the wave or what? No, we've got 2 tops. Okay, so you 2 stand together. Okay, the top of each wave. Now let's do it faster. Oh, look, we've got 3 tops. But what happens to these 2 who were standing this far apart when we have 2? What happens when we have 3? They move together. Okay? And we're out in the playground, and they love that part too. All right, so first grade storyline, physical science, life science, earth, space science, et cetera, et cetera. So all the way down through 4th grade and 5th grade. So what you see is more and more of the PS's down here till you get to the 5th grade. Whoops, y'all can't see that. The 5th grade storyline. So you've got PS 1, 2, and 3 here. Life Science 1, 2, ESS 1, 2, 3, and Engineering 1. And then a middle school physical science storyline. So see, that's a little bit different there. So in all of the standards, well, not science for all Americans because it's only high school, but in all the rest of the standards, they will do it by grade level up through grade 5. Then it jumps to 6, 8. So by the end of 8th grade, students need to know yada yada. Or 9, 12 by the 12th grade when they graduate. So they no longer put it at a grade level. I assume to give more flexibility. So, in some cases it really doesn't matter if it's 6th grade or 8th grade. But what it does matter is the math. What math do they know? So again, and we'll look at it when we get into the physical science one over here. We're going to look at what kind of math standards they have in it. Okay, so here's 5th grade. And if you look at the physical science 1, so 5th grade, PS 1, physical science 1, 1. So this is the first question, if you would, on PS 1. Develop a model to describe that matter is made of particles too small to be seen. Clarification statement. Examples of evidence could include adding air to expand a basketball, compressing air in a syringe, dissolving sugar in water, evaporating salt water. So right there it tells you activities that you can use to teach. And that's just a few of them. But it's really nice because it gives you some ideas about, oh, okay, these are the kind of activities I should think about putting in my lesson. And again, assessment boundaries. The assessment does not include the atomic scale mechanism. Remember, this is 5th grade, so you're not getting into the atomic structure. Mechanism of evaporation. So that would mean, I would also assume it would mean molecules, not just the atoms, but also the molecules. In condensation are defining unseen particles. Okay? Unseen particles. remember, at about 4th or 5th grade, students start developing a higher, greater, stronger, I don't know what you want to call it, cognitive ability to move more into the abstract. So they're saying, don't do this at the 5th grade because you may have some who are not ready for it. Then the second one, measure and graph quantities to produce evidence regardless of that type of change that occurs when heating, cooling, or mixing substances. The total weight of matter is conserved. Now, notice that term weight. What should not be there?
Mass.
Mass. Because mass is very thick cognitively. It's more abstract. And so the standards say, don't use mass in K5. So what kind of scales are you going to use in K5? You use triple beam? Why not? What?
Because that's nice.
In what kind of units?
Grams.
Grams. Grams is mass, okay? So you're not going to use triple beam balances in K5. So that'll be introduced in grade 6 through 8. It does mean examples or changes that include phase changes like gas to liquid or vice versa, dissolving or mixing that forms new substances. Assessment boundary does not include distinguishing between mass and weight. So they're very clear about some things. And they're very clear about things that might dissolve, but it does not mean that they are asking students to understand that at a molecular level for chemical reactions. And then the third one, make observations and measurements to identify materials based on their properties. Again, clarification statement, examples of materials to be identified could include baking soda and other powders. That's a common activity. They did that 30, 40 years ago in Lawrence Hall of Science. Remember I was telling you about the history of BSCS? Metals, minerals, and liquids. So these are all physical things that students should have and be working with. Examples of properties could include color, hardness, reflectivity, electrical conductivity, thermal conductivity, response to magnetic forces, and solubility. Density is not intended as an identifiable property. So that means it would not be, I'm not sure if it wouldn't be lighter, heavier relative density. I've been wrestling with that. Assessment boundary does not include density or distinguishing mass or weight. So I'm thinking, okay, does this mean that they should not be using density equals mass divided by volume? They should not be using that formula. So that's what it says to me. And really because of the math involved. And then the last one, conducted an investigation to determine whether mixing of two or more substances result in a new substance. So that's going to play into your lesson that you're going to be planning with this series of critiques that we're going to do. So you should read the disciplinary core ideas, the science and engineering practices, the cross-cutting concepts, and then look down here at how it builds from 2nd grade, etc., all the way up through middle school, and then how it might link to the science or the math. So that's how, in fact, today I was meeting with Dean Carpenter, who is the Dean of College of Ed, and I've told y'all about my dream of having a better STEM program by, I told him about you. Aren't you at Canyon? Yeah, I didn't tell him your name.
Oh.
Yeah. But I said, I have a student who is the only science person at Canyon High School. And I said they're being asked to develop lessons that are not on science and, not with best practices or any kind of guidance like that that's STEM specific. So, yes?
Yeah, even today we were talking about how we need to do a lesson in front of our class, like our block class.
Right.
And she said to do a lesson
Mm-hmm.
and not like an activity. And I asked her, I was like, well, science, is very inquiry based. Like I should be doing an activity.
an inquiry activity
Yeah,
as
and
part
so-
of your lesson.
so I kind of have to figure out how to do an activity without her thinking that I don't know.
Well, I don't know.
She wants it to be like a lesson, like how we're presenting.
I don't know what her
material.
background is, okay?
Yeah,
So, you know, I mean, you can do an activity with no sense making. Remember we talked about that earlier, my experience with elementary workshops? So,
maybe that's what she meant.
I bet that's what she meant.
Yeah.
That you're not just doing an activity, there has to be a lesson learned from it. So that would be your learning objective, using inquiry for them to discover that pattern that you're teaching. Yep, yep. Okay, so that's what you're gonna do when you start digging in and deep into the teaks. And so the part I was gonna tell you about the meeting today was that Dr. Warner, the associate dean, was saying that they wanted, you know, they were supposed to be taking these generic courses and digging deep into the teaks. And I said, well, yes, but they're not digging deep into their teaks like we dig deep into the science teaks. So, you know, how useful is that to dig deeply into somebody else's content teaks? It's not known to you, and it's not as much of an interest to dig deep into the ELA teaks or something else as it would be for you to dig deeply into science. So look for that in your class and report back and see how much you were told to or able to dig deeply into that. So we do very deep dives into the teaks. All right, so there's 5th grade. Now let's look at middle school. So you need to pull these out. You have these documents that I'm showing you here. Boy, people really should keep their fingernails clean right there whenever they use documents, right? Okay, so what you see in 5th grade looks like this, okay, 5th grade, and then look at middle school, look how much it's expanded here. So think about in your lessons, okay, so your lessons, think about any of these assessments that are in elementary or 5th grade and middle school that you could use in your lessons, okay? So it could be an exploration. It could be later on in an evaluation when you do your 5E. Remember, you're going to have an evaluation in that. So it could be in your exploration. I guess it could also be in your explanation, but not typically. But remember, these are guidelines. They're not laws. So you have to, see what you think works best for what you want students to learn. You should have a set that y'all are sharing.
Yeah.
So what are you looking
I
at?
just printed out my own copy too, so I was just trying to find it.
Okay.
There it is. Yeah.
This one.
Oh.
Yep, okay. I like
Yeah,
that.
I looked over, I was like, where is it? And I was like, oh, you have it.
Mhm, yeah. All right, so here's 5th grade, here's middle school, and then the last one, of course, is going to be high school. So, let me see if I can do this here. Okay, where are we? Okay, so here's high school, right here. Then there's middle school, and then there's 5th grade. And you might even need to go lower than 5th grade, but at least 5th grade you're going to look back at. So whenever you're planning these lessons, these 2E lessons, you're going to dive deeply into the standards so you learn how to use them. So you're learning a process as well as how to use them and what they look like and how to decompose them, if you would, because they are thick. I had a hard time learning, all about it. It took me a while to really dig into it. So you're going to dig into it 3 times. So you're going to do a deep dive 3 times, and as you can tell from the book, it has lots more in there. But you're ready for the rest of those because you know how to do this.
Yeah.
Okay? So this one is the disciplinary core ideas, DCI arrangements. So this is the one we just looked at. And we're going to look at the next one, which are the topic arrangements. And if you look at the 2 of them side by side, they look pretty similar at first glance. But if you start looking at them, y'all still read that? You're young, you look at us. Okay, good. All right, so, but if you start looking at them, you see that you've got a kindergarten storyline here and an introduction, so those two are the same. And then you had PS2K, PS2K, PS3, etc. So you got 1, 2, 3, 4, 5 discipline core topics here. But then if you look over here, you don't see the same thing. So kindergarten, you have forces and interactions, pushes and pulls. So let's see what that looks like. Because that's not what you have here. You've got motion and stability, forces and interactions. So if we look at can you see that? Can you tell anything about that? Develop a model to describe that matter is made of particles. Develop a model that describes that matter is made up of particles, yada yada. Number 2, measure and graph quantities, yada yada. Number 2 here, measure and graph quantities, yada yada.
So are these the same things, just arranged differently?
Yes,
And with different titles?
yes. Ways for you to think of it differently. So, I'll go back here. So what you want to do is you want to look at both of the ways that they have arranged them, because it encourages you to look at it from a different perspective, and it just helps you to dive deep into it. That's all it is.
That makes sense.
Okay. So it's thick, but it's doable. Francis, would you put this set back together for me, please? All right. Oh, here. Who else needs a set to work with? Who else needs a set to work with? All of you have a set to
Oh,
work
we're
with?
not sharing.
Okay. Yeah, I know some of you are sharing, so here's an extra set to open up.
I guess just like,
So, your 2E,
where do you teach it in? So just.
okay, your 2E is on chemistry. That's the topic. So, what we looked at was the chemistry in GSS. So you can know where to go to, because, where's your lesson plans? In your lesson plans, before you ever actually get into what people might call a lesson plan, you are going to have to put in all of these standards so that you know it. Are you yawning, or are you raising your hand?
Sorry, I was stretching.
It's okay, I'm just making sure I'm taking care of you if you had a hand raised. So let me show you where they fit on this lesson plan. Now, what you will note is the date, 2/6/17. So I try to date things because, you know me, I'm always trying to update it and change it. So be sure that you're looking at the newest version, and you can tell by the dates on things. Okay? So, what is your lesson topic or strand? Well, it could be chemistry, but if you look at your standards, it could be. If you look at middle school, what does it say? It just says physical sciences, right? So if we look at middle school, at middle school, where in middle school does chemistry look like it fits? Is it 1? Atomic structure? Could be.
1,
Okay, could be 1. 2, analyze, interpret data of properties of matters before or after interacting to determine if a chemical reaction occurred. Well, you got chemical, so you said, okay, could be that one. 3, gather and make sense of information, describe synthetic materials that come from natural resources. Not likely. 4, develop a model that predicts and describes changes in particle motion, temperature, and state of a pure substance when thermal energy is added or removed. Could be. So you see what I'm saying? So you're looking to see which ones of these actually fit. And so your topic or strand might be, now I'm making this up, okay? It's not the answer. So the topic or strand might be chemistry, and it might be develop models to describe atomic composition of simple molecules and extended structures. That is not the answer, I can tell you. Okay, you see what I'm saying? So you're kind of going from a big idea, it's about chemistry, to what specifically about chemistry. So you're going to make a selection there. All right, then it says, what are the prerequisite science concepts or TEKs? So how do you know what the prerequisite concepts are for science? Well, duh, I can go back to the, here's 5th grade. I can go back to the 5th grade and figure out what prerequisite concepts are and the TEKs for that. So you're not going to just look at 5th grade TEKs for prerequisite, you might want to look at 4th and 3rd grade. So what are kids supposed to have known? I was in a student teacher's room today, and they were talking about, I think it was plate tectonics, and so we went back, and this was 8th grade, so we went back and we looked at the TEKs, and lo and behold, there was something in the TEKs that they were supposed to have already known, but they were getting it again in the 8th grade. So as a real teacher, you do not assume that they've learned what they were supposed to in the previous grades. So if you're smart, you're going to also put that lesson in before you put your 8th grade TEK in real life. So that would give you that information about prerequisite concepts. TEKs, you're going to do the same thing. You're going to look back, and the TEKs, remember, are by strands also. And then prerequisite math concepts, TEKs or skills. There may not be any. That's okay. I mean, it is what it is. So if they use math in some way, ratios, proportions, or whatever, then that's what you're going to put in. Find a TEK that is a prerequisite for that. Okay, now, here's something that's different that you're going to have to do in schools. So, you have the TEKs here. You with me? So you have the TEKs here, but at the end of the lesson, the student should be able to do something, but it's not exactly the same word language as the TEKs. Usually, this is what the administration wants you to put on the board, what the students are going to be able to do or learn at the end of this period. But remember, if the lesson's going to be taught as inquiry, you can't put the answer on the board. So you have to figure out some different way of saying what the students will be able to do. So it might be the students will be able to understand if a new substance has been created when 2 other substances are mixed with it, or something like that. So you're not telling them how they would know that, which is what's in the TEKs. Then the length of the lesson. Now, you're not going to know the length of the lesson, though, until you plan it. So you're going to go back up and put an approximate length. Your first lesson, your 2E, can be no longer than about 20 minutes. Could be as short as 10. It's okay. You know, whatever it is, but no longer than 20. Okay. So your standards, you're going to put, and you're going to have an electronic version of this, so you're going to put in whatever TEKs that you're assigned. You're going to put in what the benchmarks for science literacy says, what the NSES says, the K-12 framework, and the NGSS, all on that same topic. Okay. Now, you can copy and paste those in. Okay. I'm not going to be able to tell the difference. What you need to use these for, though, is to understand that content. So, someone was talking about they were worried about not knowing the content. Was that in here, or was that one of my student teachers? I think it's one of my student teachers. And I said, well, first of all, you should know the content because your preparation requires certain content courses. So you really should know the content, but you're probably not going to deeply understand it. So if I were planning a lesson, I would dig deeply into these standards so I understood exactly what the cognitive level was and to make sure I understand the standards. Now, if I'm just talking to you about something, I can talk to you a lot about it, but if I have to plan a lesson about it, that's a different depth of understanding. When I was looking at the TEKS in, I think it was probably 3rd grade, the writing team had heat/temperature. Okay, so I'm thinking that is not the same. You know, you get this gut feeling about things. It's not the same. And sure enough, I went back and I looked it up in the standards, and it clearly defined the difference between heat and temperature. So I was able to go to the board and say, this is not correct. It should not be heat. It should be temperature, because they're talking about energy, etc. with it. Temperature, heat, thermal. I'm sorry, heat and thermal. Heat and thermal were the 2 words. So thermal is a form of energy. Heat is not a form of energy. Okay. So that's what I'm saying. You don't have to know everything, but you should know enough to think, I better check that out. You know, if it really matters. Sometimes if you're just having conversation, it may not matter so much, but if you're planning a lesson, it does. So you're going to put the standards in. You're going to put the ELPs. So here's how you're going to do it. You're going to say the students speak when they do yada yada. So it might be the students speak when they're discussing something in the activity. The students write when they're writing they're recording their observations. The students hear when they are having a discussion about yada yada. So that's what you're doing. So you're being very specific about when students speak, read, write, or hear, those 4 ELP standards in your lesson. So your lesson has to make sure that students do all of that. So it doesn't mean it's long, but they have to do it at some point. And they need to do it in small enough groups to where there's meaningful conversation and somebody can't just sit there quietly and get by with not having it. Then you have resources. Now, I left these in here, these resources, because they're all the standards. But you should have other resources other than the standards. They're not going to always give you activities and things like that you want, examples. So whatever you find, that's where you put it, because remember, these are going online, and your colleagues can download them and then they can use them when they're student teaching next year. Prerequisite knowledge. So what is it from, this is primarily middle school, what is it from elementary that they should have known about this? That's where you go back to those 5th grade, 4th grade national standards and TEKS. Misconceptions or alternate conceptions. Again, we told you that chapter 15 in the Benchmarks for Science Literacy has a chapter. Now remember, it's 15 years old. It's not everything. It has some misconceptions in there. So that's where you would make note of the misconceptions. You can also find them on the internet. This is one of the ones I told you that you could use the internet and it probably is okay. Or personal experience. So you're probably not going to have personal experience in teaching, but you will start adding to your lessons because you're going to encounter that with your students. Real life application. So that's going to go back to your black chart over there. So what is it students have in a concrete experience or a known experience, like riding bicycles or things, whatever your age kid does that might typically be in their experience. Now, you're not gonna name just one application, because you're not gonna have the same experience another student does, et cetera, et cetera. So you're gonna try to find out about your students, and that's one of the first things you do when you first start teaching, is you have these questionnaires that kids fill out, and you ask them what are their hobbies, what are the TV programs they like to do, what do they like to play with, what kind of books they read. So you're trying to find out all kinds of things about your age student, and then specifically about the community that they live in, because different communities are going to have different experiences, common experiences. So you're going to try to have as many of the real life applications that you can find. Again, that's probably something you can find on the web, as long as, along with your own experiences. But lots of examples. And then relevant STAR items. So there are release STAR tests online, you know that? Go to TEA. TEA has release STAR tests. I think they have 3 years worth now. So you're going to look at your TEKS, and you can find it by TEKS. They will have an answer key at the end of that test, and you go back there, see what TEKS it is, and they'll tell you what item number it is. That's the easiest way to go to find it. So you're going to copy and paste again what that STAR item looks like, because that tells you one way to assess it. It's not the only way, but it gives you an idea of one way to assess it. And if that STAR item has a diagram or an example, a picture example of an activity, you better do that activity or something similar, because that's what it's going to take for your students to learn it, because it's a dual coded item. That means it's content and process. Okay, then it has important academic vocabulary. Not every academic vocabulary, or not every vocabulary word is important. So I've divided it into 2 this time. This is new. I just did this today. So I've divided it into 2 sections. I've got the science word, maybe I should put vocabulary there, and then its definition goes over here. And then I have had a section here where you're going to identify less vocabulary, less important vocabulary. And the reason why I want you to think about that is this vocabulary really necessary? Or are you just throwing it in like the 7th grade teacher I told you last semester? Throwing in all of those cell organelles, and the student teacher asked why. She said, well, they need to hear the words. Why? It's not in the TEKS. You're just throwing out things that sound like you're showing off that you know all this vocabulary. So don't do that to your students, because they feel dumb, when you do that. So that's it. So that's the foundation of your studying, your preparing for the lesson. You have to do most of this, probably not how much time it takes here, because you don't know yet. Except, well, I guess you do know.